Solving linear equations. In this lesson, you will solve linear equations with rational coefficients.
Gavin likes biking. He never misses a chance to go for a ride when the weather is nice. He has set a goal for the number of miles he wants to ride this week. Now he wants to figure out how many miles he should bike each day to meet his goal for the week. He can model his situation using a linear equation and then solve it to get the answer. Solving one- and two-step linear equations should be a familiar process now. In this lesson, we'll focus on solving more complicated linear equations.
Linear equations. We can use linear equations to model real-world situations. We can model some situations using a one-step equation, while for others we need a two-step equation. And there are situations for which we may even need a more complex equation. Some complex equations may also have rational coefficients. For more complex equations, we need to repeatedly perform opposite operations on both sides of the equation, and we may need to apply the associative, commutative, and distributive properties of operations. Using these properties allows us to isolate variables and then solve for those variables.
Lesson activity: linear equations. This activity will help you meet these educational goals. Mathematical practices: you will make sense of problems and solve them. Reason abstractly and quantitatively. Construct viable arguments and analyze the reasoning of others. Use mathematics to solve real-world situations. Attend to precision and look for and make use of structure. Directions. Read the instructions for the self-checked activity. Type in your response to each question and check your answers. At the end of the activity, write a brief evaluation of your work. Activity. In this activity, you will use a variable to create expressions for various relationships. Then, you will use these expressions to form a linear equation. Finally, you will find the solution to the equation. So those are all the steps you're going to do throughout this. Each part is going to build up to that. So here's the problem. Teresa has two brothers, Paul and Steve, who are both the same height. So when we see same, we know that later that will be part of the equation. Whatever the expression for Paul is and the expression for Steve, they should be equal because this says they are the same height. Paul says he is 16 inches shorter than 1/2 times Teresa's height. Remember, Teresa's the sister. Steve says he's 6 inches shorter than 1/3 times Teresa's height. So Paul is saying he's 16 inches shorter than 1 1/2 times Teresa's height. Steve is saying he's 6 inches shorter than 1 1/3 times Teresa's height. Sounds like they're just trying to make it difficult. If they are both right, how tall is Teresa? So first, we need to identify, remember, structure and precision, and identify how tall Teresa is. That's part of the goal. To solve a problem like this one, you can use a linear equation where the variable represents Teresa's height, so we'll call that t. Let t represent Teresa's height in inches. Okay, question 1. The relationship for Paul's and Steve's height with respect to Teresa's height are described above. First, you will write expressions for Paul's height and then another expression for Steve's height. Then you will relate the expressions. So I'm essentially going to copy and paste down the bits of information from here for Paul and make a Paul says he is, I don't know why 16 doesn't copy over, 16 inches shorter than 1, and I can use the equation editor to do what I need to do. All right, so Paul says he is 16 inches shorter than one half times Teresa's height. So now I have the information. I just have to put it into an expression. That means get rid of all of these other words. So Paul says he's 16 inches shorter. So minus 16, 16 inches shorter than one half times Teresa's height. So one half times, when there's a number next to a variable, it's implied that there's a multiplication symbol right there. So 1.5 times t minus 16 should be Paul's height. We convert the mixed fraction, this is a mixed fraction, into an improper fraction, and I'm not sure why. And when we're done doing that, it becomes 3 over 2, which, by the way, 2 over 2 is 1. And then the 1 over 2 is the extra little one there, making it 3 over 2, multiplied by t minus 16 is the expression that represents Paul's height in inches. Now, for part B, we write an expression to represent Steve's height in inches. So again, copying the information from the activity where it says Teresa's height. All right. Steve says he is 6 inches shorter than 1/3 times Teresa's height. So Steve's height is 1/3 Teresa's height minus 6 inches. And again, for an unknown reason, they want us to convert that into a improper fraction. So that would be utilizing our equation editor. That would be 4 over, 3 multiplied by t, whoops, capital T for good measure, minus 6. So the expression that represents Steve's height in inches is 4 over 3 times t minus 6. And you would self-check. Bada bing, bada boom. All right, now part C. If Paul and Steve are both correct, how are their values of the two expressions related? They are equal. They're the same. They're equal. They're just saying it two different ways. Paul and Steve are the same height. So if Paul and Steve are both correct, then the two expressions must be equal. Okay, question number 2. Now, you will use the two expressions from question 1 to create an equation. Then you will solve it to find Teresa's height and then Paul and Steve's height. If Paul and Steve are the same height and they are both correct, write an equation. So now we have an equation symbol to represent this relationship. Put Paul's expression on the left. I did that. of the equal sign and Steve's expression on the right. I did that. And I just copied and pasted it from up there. And if that doesn't work for you, then use the equation editor. I also utilized the font size because it was kind of hard for me to see my screen. You can also, when on your screen, you can push Control minus and reduce the size of your screen, or Control plus and increase the size of your screen. Be careful because some features might not be there when you do that. But I do this so I can zoom in, and it just helps me as I'm working. So that's it. Let's hit submit and see how we did. So the expression that represents Paul heights in inches is 3/4 t, or 3/4 t minus 16. So the expression that represents Steve's height is 4/3t minus 6. Paul and Steve are the same height, so the equation that represents this relationship is why did they go from 3/4 to 3/2? I'm sticking with 3/2 because up here we made it 1.5. 1 1/2 was equal to 3/2. So that must be a typo on their part. I hope those that don't use this video still get that correct, because that could be really confusing. This is wrong. That's wrong. This is correct. Yay. Okay. So this is correct. That part was not. 3/2 multiplied by t minus 16 is equal to 4/3t minus 6. So then the next question becomes, what should you do to get the two terms with variables on the left side and of the equation? Variables on the left side of the equation. So that's the goal. So whenever you are trying to solve an equation, you first want to get the variables, these letters, on the left-hand side of the equation and the numbers on the right side of the equation. That's the goal. And you do that by following a couple of steps. So the first rule of getting the variable on the left side of the equation and numbers on the right, that's the goal. Let me change that. Goal. And then you do that one. So what should you do to get two terms with variables on the left side of the equation? So the goal to get the variables on the left side of the equation and the numbers are on the right. So v for variable on the left and whatever numbers on the right. You do that by following these two simple rules. Undo the functions by doing the opposite. So if it says 4a equals, then you divide by 4. 4a means multiply by 4. We want to do the opposite function to undo it. What you do to one side of the equation, you must do to the other. So if you divide by a number on one side of the equation, then you divide the other side by the same number. So in order to get these variables, let me see if I can make this a little bigger. Font size 24. So we want to get this, the t, the variable, over here on the left. So if I take that I need to undo it. I need to get rid of it. So right now, in order to get rid of 4 over 3 multiplied by t, there's no minus sign here or no subtraction here or no function here. So in order to get rid of this whole thing, I have to subtract it from this side of the equation. So I'm going to subtract 4/3 t from 4/3 t minus 6. So we're going to subtract 4 over 3t from this side of the equation here and subtract it from this side over here. What that does is it eliminates it entirely from this side. And because things like subtracting fractions are not extremely easy, and I don't necessarily want to go into a whole other lesson on how to subtract one fraction from another, I use my tools. I go to Calculator Soup, I type in the fraction, 3 over 2. I want to subtract 4 over 3. I click calculate and it says 1/6. This shows the where, why, how of that whole process if you care to know, and I highly recommend that you look it up. So now we are left with, and I think my text color is going to be wrong, but let's go bam. So we subtracted this. Edit, undo. No. Let me try again. Things happen. So, font size 24. Okay. So we subtracted this. So I want to get rid of that. All right. And we subtracted 4 over 3t from 3 over 2t. And that left us with a new fraction, which was not 3 over 2. It was 1 over 6. Is that correct? 1 over 6. That's correct. Okay. So we got 1 over 6. Okay. Whew. So now, remember it talked about precision? That's really challenging on here, but the idea that we are keeping this stuff straight and organized is really critical. Everything should be fairly straight up and down, and that will help us in organizing our items and our thoughts here. Okay, so we are left after subtracting 1/6t minus 16 equals -6. Okay, so the next part says transform the equation so both terms with the variables are on the left side of the equation. So this is the term with the variable, now both combined on the left side of the equation. And so 3t minus 4 3t minus 16 equals subtract 6. That's what we did up here. We just did the work. Okay, part D. What should you do to get both numeric terms, not generic, but numeric terms on the right side of the equation? Well, where we had the plus minus 16, remember the rule I stated. Ooh, way up here. Where did I put it? Okay, undo the functions by doing the opposite. So if it's minus 16 over here, we want to get the numbers right here, the numbers on this side. So we have to undo minus 16. How do we undo minus 16? We add 16. So add 16 to both sides. Let's double check, see if we're correct. To get both numeric terms on the right side, add 16 to both sides of the equation. That's what I said, yay! Transform the equation so both numeric terms are on the right side of the equation. So add 16 to both sides, add 16. Okay, so when it says what should you do to get both numeric terms on the right side of the equation, as I stated, you would subtract 16 from this side and from this side. Sorry, add. I'm sorry, add. You would add. I didn't mean subtract. So that would cancel it out from here and put it here. The next question says transform the equation so both numeric terms are on the right side of the equation. So negative 6 plus 16 is 10. So now we have 1/6 t equals 10. There's another way they want to do it. They want to show it with all the variables on the one side and all the numbers on the other. So I've just done these steps as we go. That's all. It says use the distributive property to make the two variable terms into a single term. I did that up here. I made this term and this term into one single term. I did that work up here. That's the only difference when it says use the distributive property to make the two variable terms into one single term. So we already have that as 1/6 t. So we already have that with the distributive property, we distributed the t across and did all the stuff. So that's correct. Then perform the operations needed on the numeric terms to combine them into one number. We already did that as we did each step. When it said subtract the t from this side over here, we did that. We did that that's what we did here. When it said add the 16, we did that. So we combined them into one number. So we already did these steps. We used the calculator soup to do that step. Okay, so now we've got 1/6 t equals 10. Great. Now it's saying here, divide both sides of the equation by the coefficient to get t by itself. How tall is Teresa in inches? So up at the top, when I said if you divide from one side, you got to divide from the other. And this space right here, it means multiply. And that means multiply. So to get rid of the 1/6, we're going to multiply 1/6 times t. That's saying 1 over 6 times t. But to get rid of it, we're going to divide. So in order to divide 1 over 6, it is the same as multiplying 6 over 1. I don't know how to make that much clearer, but let's use our equation editor here. Where did that go? And 6 over 1. Okay. So in order to get rid of this multiplication 1 over 6, we're going to divide by 1 over 6, which is the same as multiplying by 6 over 1. I know, it's weird. But we can even go back to this fractions calculator, and instead of adding fractions, we could do complex fraction calculator, multiply and divide. So we can multiply by 1/6. Okay, multiplied by 1/6. Actually, I'm sorry, we got to divide by 1/6. Right, because we're trying to undo it. This says 1/6 times t, so we're trying to undo it. So we got to divide by 1/6. All right, so 1/6 divided by 1/6 equals 1. 1/6 divided by 1/6 equals 1. Okay, so if we divide it by 1/6, then we have to divide by 1/6 over here. All right. All right, so what I did was I tried to divide to get rid of this 1/6 by 1/6. And that didn't work because then to divide 1/6, I mean, it gets to be 1t, but then to divide the 10 by 1/6 is 10 divided by 1/6. All right, so what's the fraction of 1/6 here? Clear. 1 divided by 6 equals 1 or 0.1666. Okay, so if I do 10 divided by 0.166 equals, so she's about 60 inches tall. So what I did there was I divided 1/6 by 1/6. So 1/6 divided by 1/6 equals 1. So we're left with just a t. Now over up there, let me see. Copy, paste. So I want to divide. So let me make a little division bar here. Divide. So 1/6 divided by 1/6. I'm going to get rid of that. And we did that right here. 1/6 divided by 1/6 is left with just t. Okay. Equals So now I have to divide the 10 by 1/6. So 10 divided by 1/6. So let's look at 10, which is the same as 10 over 1. Okay. If 1 is the whole and I have 10 of them, 10 over 1 is 10. I can prove that with a calculator if need be. 10 divided by 1, or 10 over 1, equals 10. So I'm not making stuff up here. And then I need to divide it by 1/6. I need to get rid of the calculator. I need to divide this by 1/6. And copy. Put it right here. Division symbol here. Where's my division symbol? It would be another straight line. Divide by, and I'll just put the 1/6 there. I know that looks weird, but again, we have these tools. 10 divided by 1/6, so calculate, and the answer is 60. All right, so put that right here, 60. How does that make sense? Well, if I take 10 and I divide by 1/6, I am dividing by what 1/6 equals. So 1 divided by 6 equals 0.1666. Okay. 10 divided by that, 0.166, equals 60 and a little bit left over. So Teresa, equals 60 inches. Does that make sense? Yes. 60 inches is, there's 12 in a foot, so 12 inches in a foot. 60 divided by 12 equals 5. So she's 5 foot tall. If Paul, one of them's, who's 6 more? So Paul says he's 16 inches shorter than 1/2 times her height. Right? So it works. Okay. Now that you know Teresa's height, 60 inches, right? T equals 60 inches. Find Paul's and Steve's height. And the way you do that is to plug Teresa's height into the expression for Paul's height and then into Steve's height. How tall are they each in inches? Are they both the same height? So this is the check. So if we get that T equals 60 and we plug it back into the one for Steve's height. Steve is 3/4 T minus 6. And then we do the same thing for the deal with Paul, which was the 3/2 over. All right, so we're going to do that. So for Paul, we're going to cut that, copy, scroll all the way back down. All right, so we're going to take this. That one's for Paul, yeah? And then what's the one for Steve? This one's for Steve. Dang it, I keep pushing the wrong buttons. Copy, that one's for Steve. And now remember, for precision, we want to do that one equals for Paul. And this one is for Steve. Okay, so now we can solve this. And the way we do that is by taking the 60 that we now know, because we solved for it, and put it into here. 60 and 60. Now we solve this. All right, so what is 3 over 2 times 60? So that's what we're going to do. So 3 over 2 multiplied by, and I'm going to use the same trick, 60 over 1. That gives us the fraction of 60, and calculate. So that's 90. So now we have P equals 90 minus 16. I'm going to go ahead and skip down to this one and do the same thing since we're in that mode. So 4/3 times 60 over 1 equals 80. So S equals 80 minus 6. Okay. All right, so now, sorry, a little being weird here. Okay, so now we do the simple subtraction. 90 minus 6 equals 84. Is that right? Is that where we were? I don't know why that jumped up. 90 minus 16, I'm sorry. 90 minus 16 equals 74. So Paul's height in inches equals 74. All right, now let's do the Steve's height, which equals 80 minus 6. I can do that one in my head, but just in case, 80 minus 6 equals 74. So Steve's height equals 74 inches. Are they the same? Yes. Paul and Steve equal 74 inches. Hit submit. Double check. Blah, 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 blah. 74 inches. Blah, 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 blah. 74 inches. Yay! Paul and Steve are the same height. They are 74 inches. We proved it. Why they had to make it all difficult, I don't know. But there we go.
Let's solve another problem to review how to create and solve a multi-step linear equation. Alec, Ben, and Cedric collect coins. Alec says he has 5 less than 1 2/3 times the number of coins Ben has. Cedric says he has 12 more than 1 1/2 times the number of coins Ben has. If Alec and Cedric have the same number of coins, how many coins does Ben have? How many coins do Alec and Cedric each have? To solve this problem, first, assign a variable to the quantity that is common to the other two quantities. The number of coins Ben has is common to the number of coins Alec and Cedric have. So let B represent the number of coins Ben has. Once we have a variable for the number of coins Ben has, we can form expressions for Alec's and Cedric's coins that depend on the number of coins Ben has. Form expressions based on the given information. Alec's coins, 5/3 B minus 5. Cedric's coins, 3/2 B plus 12. Create an equation by using the relationship between the two expressions. Alec and Cedric have the same number of coins, so we can set the expressions for their collections equal to each other. 5/3 B minus 5 equals 3/2 B plus 12.
Sometimes it doesn't let me highlight this section again, but it did. There we go. Create an equation.
Perform opposite operations and apply the properties of operations to get the terms with variables on the same side of the equation. 5/3 B minus 5 minus 3/2 B equals 3/2 B plus 12 minus 3/2 B. 5/3 B minus 3/2 B minus 5 equals 12.
So these are the same steps, just in a compact form as we did with the last problem. Instead of doing step A, step B, step C, step D, step E, step F, it's all right here. But it's the same idea. We're making an expression, and then another expression, and then determining that they are we're putting them as an equation, and then we are doing the getting the variables by themselves part. So for example, here is the 3/2 B. This is the 3/2 B. We now subtract it over on this side, and then so it becomes 5/3 B minus 3/2 B minus 5 equals 12. So now we're at the perform opposite operations and apply the properties of operations to get the terms with the variables on the same side of the equation, exactly like we did before.
Apply opposite operations to get the numeric terms on the other side of the equation. 5/3 B minus 3/2 B minus 5 plus 5 equals 12 plus 5. 5/3 B minus 3/2 B equals 12 plus 5.
Oops, at some point I didn't hit the recording button, so I'm hoping I'm at this step where it says apply opposite operations. If I messed you up, I really apologize. But essentially what we're doing is the exact same steps from the last one, but instead of breaking it down on the example, step A, step B, making the expressions, then making the expressions into an equation, then getting the variable by itself over here, not getting it by itself, but getting the variable on the left-hand side of the equation. And then what we're going to do is get the numeric values on the right-hand side of the equation.
Solve for the variable by using the distributive property and opposite operations where needed. 5/3 B minus 3/2 B equals 12 plus 5. The difference of 5/3 minus 3/2 times B equals 12 plus 5.
Okay, equals 12 plus 5. Now, remember, we don't have to know how to do the 5/3 minus 3/2. We can go to this, we can do, what is it, 5/3 minus 3/2 and calculate. Equals 1/6. So, see? Equals 1/6. They are doing multiplication, so we multiply 3 times 2 to get 6. That's a common denominator. And then if we multiplied this one by 2, then we multiply this by 2. That's how you got the 10. If we multiply the 3 by 3, that's how we get the 9. And then the negative sign still stays there. So 10 minus 9 equals 1/6. See? 1/6. They have 12 plus 5 equals 17. I'd like to highlight that. I don't know if I can. I can't seem to highlight that. That's unfortunate. Yeah, it won't let me highlight it. That would sure be nice. All right, and then it's simple multiplication of the 6 to get the b by itself. 17 times 6 is 102. 17 times 6 equals 102. Remember, use your tools. Don't try to do this stuff in your head. That's insanity. So Ben has 102 coins.
Plug the variable's value into the expressions to find the values of the other quantities. Alec's coins equals 5/3 b minus 5, equals 5/3 times 102 minus 5, equals 170 minus 5, equals 165. Cedric's coins equals 3/2 b plus 12, equals 3/2 times 102 plus 12, equals 153 plus 12, equals 165. Alec and Cedric have the same number of coins, 165.
And all they're doing is plugging in what Ben has for the b in their individual expression to see if it's true and accurate.
We created and solved an equation to find the number of coins that Alec, Ben, and Cedric each have. When creating and solving equations, it's a good idea to have a strategy. A strategy can help us identify the unknown variable and then build an equation to solve for that variable. First, identify the quantity that can be represented with a variable. This variable is usually a quantity for which we don't know the exact value. However, this variable should be a quantity about which some things are known. In the coin example, we didn't know how many coins Ben had, but we knew how many coins Alec and Cedric had compared with Ben. After building the equation, simplify it using opposite operations. Always perform the same operation on both sides of the equation. That way, the equation is always equivalent to the original equation. Become familiar with the properties of operations. When transforming equations, these properties let us know whether we are using an operation correctly. Solving equations can be a long process, so it's a good idea to recheck the work at the end. For example, in the coin problem, if the number of coins had been different for Alec and Cedric, that would have indicated a mistake had been made.
In this problem, it gives us a ton of information and, unfortunately, nowhere to do the math. So without a scratch piece of paper or some sort of writing surface, in the previous examples, we had a deal that looked similar to this where we could write it out. This is the absolute worst way to do math. On paper, in straight lines, that's the way to do it. But we're not given that. This is what we have. So in class, I would write this on the board or use the overhead. For right now, I'm recording it without that, so I have to make a place to put this information because the first thing I have to do is write her expression. So I've highlighted the information. Bridget went fishing with her dad and caught the first fish of the day. So F. Let me increase the font size. F. It weighed F ounces. So F is fish ounces. That's the variable we're going with. She caught four more. So we've got plus 4. Oops. Plus 4. Sorry, I misspoke. So let me back up. We have no place to do this work. So I have to do the work off to the side. I was trying to do 2 different tabs and that wasn't working. Here we go. So we have F ounces. It's not letting me type in the text box. Okay. Okay. F is for the first fish. She caught 4 more fish. The first one that she caught, the second one was 2 times the weight of the first fish. So plus, and I know this is probably super small. Let me try to do that. So F plus, what is it? 2 times the weight of the first fish. So that's 2F, not 2 F's, but 2F. And then she caught another one was 2 more than 3 times the weight of the first fish. So she caught another one was 2 more than 3 times the weight of the first fish. Whew. So what that means is the next one she caught plus was 3 times F plus, dang it, Bobby, plus 2. 3 times the first fish and 2 more. So 2 more than 3 times the first fish. Yeah. Get that. Okay. Plus. Dang it. Plus. The next one was half the weight of the first fish. So 1/2 F. And the last one was 3/5 the weight of the first fish. So plus. Dang it, Bobby. Plus 3/5, not 2/5, 3/5 the weight of the first fish. So this expression is all to explain how many ounces of total fish that Bridget caught. That's Bridget's. So Bridget's ounces. Ounces of fish. Bridget's ounces of fish. Bam. That's her expression right there. Okay, next we need to make the expression for the weight of fish in ounces that Bridget's dad caught. So dad's ounces of fish, we need to, and I went through and I highlighted as best I could the parts of the equation that were, the parts of the word problem that we're pulling out to go into the expression. So we've got, the first one is 2 more than 3 times the weight of the first fish. So we say that it is 3F plus 2. All right. Again, that's, let me zoom in. Oops, out one more. Hi! I don't know why my video's on here, but let's get rid of that. Boop. Okay, so 2 more than 3 times the weight of the first fish. 2 more than 3 times the weight of the first fish. F. Okay. Plus one fish weighed 4/5 the weight of the first fish caught that day. So 4/5 F plus a fish that weighed 4 more than 2 times the weight of the first fish. So 2 times the weight of the first fish plus 4 more. Okay, so 2 times, 2 times, 2 times, and 4 more, and 4 more. So it's 4 more than 2 times the weight of the first fish. And the last was half the weight of the first fish that was caught that day. Whew, plus half F. Okay, so Dad's ounces of fish were 3F plus 2 plus 4/5 F plus 2 times F plus 4 plus half F. All right, sounds good. So if all the fish Bridget caught have the same total weight as all the fish her dad caught, okay, so the same total weight, Bridget and Dad. So now I know that this equals this, all the weight that Bridget got and all the weight Dad's got are the same. I now have an equation. Okay, so these are equal. Then the first fish Bridget caught weighed blank ounces, and the first fish her dad caught weighed blank ounces. So now I have to solve this. The first step in solving it is getting all the like terms on the right side. So all the F's on one side and all the numbers on the other. That's going to be really challenging on this workspace here, but let's see what we can do. Okay, I'm going to try to do this again. No, that's not it. Where did my other tab go? Dang it. Pause it again. Once I had the expression all written out on the blank spot that I could do the work from, I mean, I'm using a self-evaluation from a different page in order to do this, but after we have the first expression and the second expression, number of ounces Bridget caught, number of ounces Dad caught. Now I'm simplifying this out a little bit. So the way I did that was I looked at the terms that are similar and put them together. So one fish, red fish, two fish, two fish. So this would be red, and this would be red, and this would be red, and this is red, and this is red. See? 1, 2, 3, half, 3/5. Everywhere there's a space, or sorry, a number right next to the letter, a number right next to the letter, a number, even if it is a fraction, right next to the letter, and a number, it's not this alone +2 number. We can put those together and make 1 plus 2 plus 3 plus half plus 3/5 multiplied by f plus 2. The plus 2 and the plus 2. So that's how we simplified that. And we're going to do the same thing to this side. Okay, so we have 3 4/5 plus 2f. I may have made a mistake. One moment. 3 4/5 plus 2 plus half f plus 6. Okay. Sorry, I got my numbers messed up here. Let me back up. So we have 3f. We have 4/5 f. We have 2 f's and half an f. Then we have plus 2 plus 4. 2 plus 4 is 6. So Bridget's simplified, Dad's simplified. Now we have to just solve this out a little bit, to get it more usable or simplified. All right, so once we have 1 plus 2 plus 3 plus half plus 3/5 multiplied by f plus 2 and equals 3 plus 4/5 plus 2 plus half multiplied by f plus 6, then we break it down. So 1 plus 2 plus 3 equals 6. Half plus 3/5. Half plus 3/5 equals 1 and 1/10. So we have 6 plus 1 and 1/10. We would take that and look at 6 plus 1 is 7, right? And I'm keeping it color-coded here. Well, I'm trying to keep it color-coded. Plus 1 1/10. 1/10. Okay, so then it just keeps getting simpler and simpler. All we're doing is putting things together, adding them together, doing the fractions math. I used the fraction calculator to get these terms, and that's all we're doing. And then trying to keep it color coded so that way you can see the terms that are, like I said, alike, if you will. And so you can see where those numbers came from. So that's all we're doing, was just keep doing that. Okay, so we've taken our sixth and 1 1/10, and we've combined it to make 7 1/10 multiplied by f plus 2 equals. We've taken our 5 and 1 3/10 and combined that to be 6 and 3/10 multiplied by f plus 6. So now our goal is to get the f's all together and on one side. And so in order to do that, I'm going to make this a improper fraction, so that way it matches with this as an improper fraction, and it makes it a little bit easier to do the math in the next step. All right, so we went from 71 tenths, and over here we had 63 tenths. Remember, to get rid of, to undo, we had to we want the variables all on one side. So to undo this, we subtract 63 tenths f, f, make that black just for giggles. Okay, oops, I didn't make it black for giggles. All right, so we're going to undo this from this side and bring it over here. So now we've undone this. This side is gone. This 63 tenths is undone. It's not on this side anymore. So on this side, we are left with this plus 6, which I will bring down and put right here. Plus 6. Okay. So once we take 63 tenths away from 71 tenths, 71 minus 63 is 8. 63 tenths subtracted from 71 tenths is 8 tenths. 71 minus 63 equals 8. Then we reduce that down to 4/5. It's simple, divided by 2. 8 tenths is the same as 4/5. So now we have 4/5 f plus 2. Change that to black for continuity. Change this to blue for continuity. And change that to black just for giggles. Okay, so now we have 4/5 f plus 2 equals 6. Okay, see this plus sign? That's just a carryover. It's a given. I could delete it. I could get rid of it, but we're going to leave it there just so you know it's a positive 6. So now we have 4/5 f plus 2 on this side of the equation and plus 6 on this side of the equation. So in order to get rid of this plus 2, I need to subtract 2. Now I've gotten rid of this plus 2 by subtracting 2. What I do to one side, I gotta do to the other. 2. I'm gonna keep it nice and as organized as I can. I don't know why I copied a black deal and it made it red. Oh well. So you hopefully won't ever have to do this complicated on here. Get scratch paper, use scratch paper, keep everything in a nice neat line as best you can. All right. So then you are left with 4/5. Oh man, and it's blue. Let's change that to red. Again, just for continuity. F. I don't know why I do this to myself. Oops, I went too far up. Okay. So 4/5 F equals what's 6 subtract 2 is 4. We can make that blue just for giggles. At least we're having fun giggling and stuff. So now we have 4/5 F equals 4. Whew. So if you remember earlier when I confused us, we are multiplying the reciprocal to undo this, which means down here, I'm going to multiply by 5/4, and that's going to be red, and hopefully my dog barking doesn't interrupt my flow here. So that's going to be red, right? And then we've got the F. Let's see if we copy it down and see if it, nope, it's going to make it red. All right, so we got to multiply. This is multiply here. Multiply. Dang it. Multiply. Undo it. I did the math on the other one and showed you how to do it. I'm not going to go through that again, but if you need help on it, ask me. I'll screw you up and then we'll hopefully figure it out. But okay, so then on this side of the equal sign, we have 4 multiplied by 5/4. Make that blue, but it doesn't really matter. Okay, so now 4 times 5/4. 4 times 5/4. I think I can figure that out, but just in case, let's do this. 4/1 multiplied by 5/4, calculate, equals 5. Whew. So, by itself, the first F equals 5 ounces. Wow. So, Bridget's first F, Bridget's first fish, her first fish equals 5 ounces. Okay. The key to this is on your paper, you want to be very precise. If you remember in one of the learning goals, what you will be able to do, it's practice precision. So even on this, I kind of get my equal signs start getting thrown off. The more that we can keep this straight up and down, the better you're going to be. It's just about keeping it clean and organized. Okay? That's going to help you in the long run. I don't expect color coding or anything like that. I just did that so you could see, because it gets really jumbled really fast. All right, so now we know that she has 5 ounces for her first fish. So going back to the problem, if all the fish Bridget caught have the same total weight as all the fish her dad caught, then the first fish Bridget caught weighed 5 ounces. And the first fish her dad caught weighed how many ounces? Okay, now we have to go back. My course session is no longer valid. Okay, I'm back. Whew. So her first fish, Bridget's first fish caught, weighed 5 ounces. We figured that out through doing all of that work. So where Bridget's fish equals 5 ounces, we substitute into. So now it wants us to figure out her first, how many, the ounces of dad's fish, the first fish her dad caught, in ounces. Now, I don't know if you remember, but Bridget's dad caught 4 fish. The first fish he caught weighed 2 more than 3 times the weight of the first fish Bridget caught that day. 2 more than 3/5 the fish, 3 more. Let me back up. The dad's fish was 2 more than 3 times her first fish. So if we substitute the 5 in for her first fish, we've got 5 here. 3 times 5 plus 2 equals 15 plus 2. So we got this multiplication. All right. So 15 plus 2 equals 17. All right. Whew. So the first fish Bridget's dad caught weighed 17 ounces. Let's put that in and see if we're correct. Holy cow, that was a ton of work. Yay, we got it correct. Look, they make it look all easy. They got all that mumbo jumbo spread out. Da 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 da. Bam, 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 bam. And they expected us to do this without any worksheet area. So get yourself some pen and paper. Come by, pick it up from the classroom, whatever you got to do. Or open up something and do your best. But that's how you do it. That's how you solve that. Whew.
Combining like terms. In a single variable equation, there are terms with a variable and terms without a variable. We refer to these 2 sets of terms as like terms. The table contains examples of like terms. To solve a linear equation, we need to combine the like terms. Earlier, we applied opposite operations and the associative and commutative properties to group like terms. Then we applied the distributive property to combine them. We call this process of working with linear equations combining like terms. To solve a linear equation, we need to combine the like terms. Earlier, we applied opposite operations and the associative and commutative properties to group like terms. Then we applied the distributive property to combine them. We call this process of working with linear equations combining like terms.
Remember, if you need to know what these properties are called, we did look them up in previous lessons, but you can go to the dictionary and look them up. Okay, so producing the same mathematical value no matter how an expression's elements are grouped, so long as the order of those elements is the same. Okay, or commutative. And we did put these in our notes in an earlier lesson, but those notes don't save. So that's not very helpful. So having or being the property of giving the same mathematical result no matter in which order two numbers are used with an operation. And distributive. So having or being a property of giving the same mathematical result when an operation is carried out on a whole expression and when it's carried out on each part of an expression with the results then collected together. So whether it's 3x plus 2x or 3 times 2 plus 3. There's something to that effect. I hope that didn't confuse you. Okay, continuing on.
Let's combine like terms in an expression. 3x minus 2 plus 4x plus 7. The terms 3x and 4x are like terms, and so are the terms negative 2 and 7. The like terms are highlighted in this expression.
So remember how I was highlighting and moving things around? That's what they're doing here. They're highlighting the like terms. 3x plus 4x are like terms. So they switched them by applying the commutative property. So, 3x and 4x. Let me see here. 4x. Bam. 3x and 4x are like terms. Oh, darn. Let's do it blue. Remove the highlighting. Okay. Let's do it blue. Why? Because they did it blue. Bam. Bam. I'm not going to do that in the future, but the 4x is highlighted. Bam. They're like terms. So are the terms negative 2 and 7. All right, so the negative 2 and the 7 are like terms. I can't highlight that one. Okay, I'm going to continue on.
3x plus negative 2 plus 4x plus 7. First, apply the commutative property to get the like terms side by side. We apply this property to group the x terms and the numeric terms. 3x plus 4x plus negative 2 plus 7. Then use the associative property to group the terms. The sum of 3x plus 4x plus the sum of negative 2 plus 7. Finally, use the distributive property wherever required to add or subtract the like terms. The sum of 3 plus 4 times x plus the sum of negative 2 plus 7 equals 7x plus 5.
In this activity, you will create a linear equation to model a real-world situation. Then you will solve the equation to find the solution. Gavin likes biking. He never misses a chance to go for a ride when the weather is nice. This week, his goal is to bike about 65 total miles over 4 days. Remember in health class about setting realistic goals and being flexible? Each day, he wants to ride 1.5 times as far as he rode the day before. How far should he ride on each of the 4 days to reach his goal? So on day 1, he wants to ride a amount, and then on the next day, he wants to ride 1.5 times that amount, and then day 1 and 2 times 1.5, and so on. So question 1. To solve this problem, first you need to write the expressions for the distance Gavin needs to bike each day. Then relate these expressions to create an equation that represents Gavin's situation. So just like before, we need to make 2 expressions and then make them into an equation. If x is the number of miles Gavin bikes on the first day, so remember we're using x as a variable. We're not using x as a multiplication symbol. If we need to use multiplication, we will put the variable next to the number, so x multiplied by 7, or a number in front, so 3x plus 2, for example. Okay, the multiplication is implied here, or the other way we can do it is parentheses and do, like, let's say a 3 out here. This would use the distributive property 3 times x and then 3 times 2. So that would equal 3x plus 6. Okay. And I'm just showing you that because I know that even at high school level, we forget that the x is not multiplication. So that's why I just showed you that. I know that's making the video longer, but I was trying to help. So if x equals the number of miles that he goes per day, on the first day, write an expression for the distance he should bike on each of the following 3 days. On each day, he wants to ride 1.5 times as far as he rode the day before. So on day 1, he rides X amount of miles. On the second day, he rides 1.5 times X. The third day is 1.5 times day 2, which is 1.5 times x. 1.5 times 1.5 equals 2.25x. 1.5 times 1.5 equals 2.25. Okay, I straighten these out so that way your 1.5x, 1.5x, and 2.25x line up just a little bit better. So we can see that these equal this, and so that's there. On day 4, it is 1.5 times the 2.25x from day 3 equals 3.375. 1.5 times 2.25 equals 3.375. Bam. Since the goal and the total distance he should bike over the 4 days must equal 65. The total mileage needs to be 65 miles. So we take x, the first day, plus 1.5x for day 2, 2.25x for day 3, and 3.375x for day 4, and clean that up a little bit. And what that gives us is the equation. So we've taken the expressions, expression for day 1, x, expression for day 2, 1.5x, expression for day 3, 1.5x times 1.5x, expression for day 4, 1.5x multiplied by 2.25x. So we're just taking what that expression equals. So that's an expression, that's an expression, that's an expression, and putting them where they go. And I can make those pink for us because that's fun. Bam. Okay. All right. We don't want any signs getting in or making us all confused. All right. So now all we have to do is simplify that and solve it. Okay. Whew. Simplify and solve. To simplify, we're going to add all of these together. So on our calculator, we have 1x plus 1.5x plus 2.25x plus 3.375x equals 8.125x. So 65 equals 8.125 x. I think that's going to be pink, but that's okay. So now, remember, we want to get the variable on one side and the numbers on the other side. So here's what we got to do. All right, and then if you remember, in order to get rid of the numbers in front of the variable, we have to undo it. So 8.125 multiplied by x, to undo that, we need to divide this number out. So I would essentially be dividing, here, let's even use a pink here, divided by 8.125. And then we should have 65 divided by 8.125 equals x. All right, just for giggles. So we got our 8.125 divided by 8.125. We bring that over onto this side. We then are left with an equation that if we kept it lined up a little bit, I'm going to mess it all up, ain't I? So this equal sign and that equal sign should be right above each other. But 65 divided by 8.125 equals x. If I do that math on the calculator, 65 divided by 8.125 equals 8. So 8 equals x. What does that mean? That means 8 miles on the first day. And we can then work to check that. That's probably what some of these are going to be doing. So let me see if I did all the work on part 1. But so the first part A, says if x is the number of miles Gavin bikes on the first day, write an expression for the distance he should bike on each of the following 3 days. So right here is that expression. That's all I had to do on part A. So then part B says write an expression representing the total distance he should bike over the 4 days in terms of how far he bikes on the first day, x. Do not combine like terms. So that was this step, I think. That should go. Okay, that's close. Yep. The expression Gavin distance. The expression for distance Gavin should ride each of the following 3 days is 1.5x, 2.25x, and 3.35x. That's what we did up here. Bam. So now write an expression, the total distance he should bike over the 4 days in terms of how far he bikes on the first day. I believe that's it. Yep. So the expression representing the total distance of 4 days is, oh, I'm sorry. It's just that. Okay. Because he's going 4 day, 65 miles, what equation can we use? 65 equals x plus 1.5x plus 2.25x plus 3.35x. We did all of that up here. We did all of that. Unfortunately, because for me, it's easier to work step by step by step by step, they broke it down. Part A is to here. Part B was to here. Part C adds the 65 part on there. Which terms in the equation you found in part C are like terms involving x? These are all the like terms involving x. Now, because the whole point of this is adding like terms, now that you have the equations, solve it to find the number of miles Gavin should ride on each of the 4 days. We did that, and it is 8 miles. Oh, sorry. To solve to find the number of miles Gavin should ride on each of the 4 days. Okay, so 8 miles on day 1. Day 1 equals 8 miles. So if that's day 1 is 8 miles, then 1.5x day 2 equals 1.5 times x, so 8. 1.5 times 8 equals 12 miles, so equals 12 miles. Oops. Sorry, guys and gals. Day 3. What'd I do? I think I zoomed in. Okay. day 3 equals 2.5x, which, if we then put 8 there, (2.25) multiplied by 8 equals 18. And finally, day 4 equals 3.375 multiplied by 8 equals 3.375 times 8 equals 27. Now, this is fairly realistic. In my older, not very good shape, I could ride 8 miles, and then the next day ride 12 miles, and then the next day ride 18, and the next day ride 27. Now, here's the check. We got to solve for x. We already did that. I don't understand. We did that. It's 8. Okay. Use the expression from part A of question 1 to find the number of miles Gavin should ride on each of the 4 days. I'm pretty sure we just did that. Copy. Maybe I'm confused. I don't know. So, there you go. Now, add the number of miles you found for each of those 4 days. Does it come out to 65? That's our check. All right. Now, I don't know about you, but I cheat. I'm going to do the calculator business. But like I said, I kind of cheat a little bit. Oops. I meant to clear that out, not close it out. Hey, Siri, what is 8 plus 12 plus 18 plus 27?
8 plus 12 plus 18 plus 27 is 65.
Whoop, yeah. So, there's more than one way to do this type of thing. So it does equal 65. We did it correctly. We checked it. Submit. 65. Yeah. All right. Nice. What does your result in part D mean? So what does this result mean? It means that we did the math correctly. We solved for x correctly. I don't know if that's what it's going to say when I hit submit, but the result from part D confirms. That means we did it correctly. Confirms is positive. Gavin should cover on each day adds up to 65 miles. So the number of miles Gavin should ride each day of the 4 days is 8, 12, 18, 27 is correct. We do our self-evaluation. The hardest part of this was keeping everything in order. We hit submit. Awesome. Somewhere I didn't hit submit, and it won't let me move on until I do. Make sure you check yourself before you wreck yourself. And bam. All right.
Solving the problem about how far Gavin should ride each day to meet his goal required combining like terms and then solving. The table shows these distances and Gavin's goal. It's good practice to recheck answers whenever possible to make sure the calculations were done correctly. In the lesson activity, adding up the miles Gavin rode each day to determine whether they totaled 65 miles was one way to check the answer.
Bam. This is really not... Okay, so I highlighted those. All right. All right. Okay, one way of checking the answer and making sure that the calculations were done correctly is by adding up the miles. Oh man, this is so frustrating. I'm trying to make this all visible and clear, and it's just becoming crazy. So, is by adding up those miles and seeing if they totaled 65. If the total was 65. Awesome. We did that. So for this first one, and I'm not going to try to use all this wonderful blank space. I'm going to try to solve these as quickly as possible. I look at the like terms. I need to get minus 5 over 2x on this side of the equation. So I'm going to subtract 5 over 2x and get it onto this side. So I'm left with minus 4 on this side, just this minus 4. Well, I'm going to add 4 from this side, cancels that out. Add 4 to this side. Negative 4 plus 4 is 0. So now I have 0 on this side. So no matter what I do over here, x, or fractions of x, is going to equal 0. So, done. For this one, we're going to look at combining the like terms. So I'm going to add the 1.7b onto this side, which is going to make it 4.9b. And then I'm going to subtract the 10 from this side over here, minus 10. Well, I've already got a negative number, so now it's going to be even more negative. It's going to be negative 14.7. Then I apply the distributive property, and I'm going to get the, what was it, 4.9. I'm going to divide that, divide by 4.9, and 14.7, 14.7 divide by, what is it, divide by 4.9, I think it was, equals 3. It's a negative 3. I know that because it was a negative 14.7 minus 10 to get rid of it. So minus 10. So that's going to be negative 14.7. So I know the answer is negative 3. Whew. All right. On this one, it's going to be, let's see here. I'm going to add the 6.7 onto this side. Or sorry, I'm going to subtract the 6.75 from this side, subtract it from over here. I'm going to minus the y from here and add it over here. And then I'm going to, so that should leave me with 6.6y. Oh, so when I subtract this y from this y, I'm left with 6.6y equals negative 13.2, and 6. I got to divide the 6.65 or 6.66 to get rid of it. And what I say, that was negative 13.2 negative divided by 6.6. 6.6 equals negative 2. That's that answer. Bada bing, bada boom. The last one's going to equal 5. How do I know? Because it's the last one there. But just in case, let's look at it. We're going to put 2c minus 7c. 2 minus 7 is negative 5. Negative 5c. I'm going to get rid of this 8. Minus 8. Minus 17. Minus 8. So 17 minus, minus 17, subtract 8 equals negative 25. What did I say this was? Negative 5. So I got to divide negative 25 divided by 5. That is negative equals 5. Bam. Submit. And we got it all correct. Awesome. How do I push the play button?
We can use linear equations to model many real-world situations. In this lesson, for example, we wrote and solved linear equations to find the heights of 3 friends, to determine the number of coins each of 3 boys had, and to find the number of miles Gavin had to bike each day to reach his goal. To solve a linear equation, we need to get a variable term alone on one side of the equal sign and a numerical term alone on the other side. The first step is to use opposite operations to transform the equation. Performing the same operation on both sides of the equal sign keeps the transformed equation equivalent to the original equation. Once the variable terms and numerical terms are on opposite sides of the equation, we can apply the associative and commutative properties to group like terms. The associative property lets us freely group the terms on each side of the equation. The commutative property lets us reorganize terms into like terms. The distributive property is helpful for combining like terms. Combining like terms means adding or subtracting the terms with the same variable and the terms with no variable. Wherever possible, it's a good idea to recheck answers. Substitute the answer back into the equation to check whether it holds true. That will confirm the calculations are correct.
Whew, congratulations, we've completed the tutorial solving linear equations. If you're still hanging on after all of that, that was a wild ride. Note to self, use scratch paper, keep things straight and in order, and when in doubt, read the directions again and go step by step. Have a great day, and thank you for surviving another math lesson. Solving linear equations tutorial.